Today we're going over CCM8, Unit 2, Lesson 4, Estimating the Value of Irrational Numbers. Some definitions for you. A rational number is any number that can be written as a fraction, positive or negative. Irrational numbers are any number that cannot be written as a fraction, so any non-repeating, non-terminating decimal. This is like pi, or the square root of any non-perfect number, non-perfect square. So Vic, number one, very important concept, number one, make a table of perfect squares to help you. So you've got this table on your paper, go ahead and fill it out with all of the perfect squares. I'll give you a second to do that. Just pause the video. Once you've done that, now we're going to go through and actually simplify these non-perfect square roots. So when we start simplifying, we have to ask ourselves, okay, we've got the square root of 32. What times what gives me 32? I want to pick one of these numbers, one of these perfect squares, and I want to say, is 32 divisible by any one of these? Is it divisible by 4? Well, yes it is. But if it's divisible by 4, 4 times what? 4 times 8 makes 32? Well, 8 is also divisible by 4. And what we're trying to do is we're trying to take out or pull out any perfect square that we can and get it out of the radical sign. And that's how we simplify. So it's divisible by 4, but it's also divisible by 16. And I'm going to take the greatest perfect square that I can, and I'm going to pull it out. So this is how I'm going to write it. I'm showing my work here. The square root of 32 is made up of the square root of 16 times 2. 16 times 2 is 32. So what I'm going to do is I'm going to literally take the square root of 16 and get 4. So I've simplified this portion of my problem. What's remaining is the square root of 2. I can't simplify that any further. So this is actually the simplest form of this radical. And that's what we're doing today. So let's try number 2, 18. Look up at your chart and think, what perfect square down here goes into 18? 9. Okay, 9 times what? 9 times 2 gives you 18. Well, I can take the square root of 9, which is 3, and what's left? The square root of 2, and we're done. Why don't you try these two down here? Why don't you just pause the video, try them yourself, and then when you're done, hit play, and the answers will be here on the screen. Did you get 2 times the square root of 5 and 5 times the square root of 3? I hope so. Here's a way you can check yourself. In your calculator, you can type in square root of 20, enter, and leave that long decimal on your screen. Then hit 2 times the square root of 5 and hit enter, and compare the two answers you get. This answer in decimal form and this answer in decimal form on your calculator should be exactly the same. That's how you know you did these right. Why don't you do these last 3 examples, try them out, hit pause on the video, and then when you're done, hit play, and you'll see the answers on the screen. For number 5, did you get 2 times the square root of 14? Number 6, 2 times the square root of 10. And number 7, 3 times the square root of 11. Well, I hope you did well. Welcome back to CCM8 Estimating Square Roots. Today we're talking about estimating the value of each rational number. Estimating the value of each irrational number. So this number is an irrational number because it is not a perfect square. Therefore, if I found the exact answer, it would be a non-terminating, non-repeating decimal. So these values are irrational numbers. I'm going to estimate its value in rational form. So I'm going to see what number this value comes closest to. And I'm not going to use a calculator to do this. So here we go. We've got the square root of 15. Well, I know that if I square the number 4, I get 16. Okay, that's a little bit above 15. Well, if I square the number 3, I get 9. That's a little under 15. If I square the number 5, I get 25. Square rooting is an inverse of squaring something. So if I undid the squaring part and took the square root, these statements would be equivalent. So what I'm looking for is the square root that is going to get me closest to 16, or the perfect square that's going to get us closest to 15. And in that case, it's this one here. So the square root of 15 is approximately 4. That's as close as we're going to get to the whole number value. You can always check your answer by picking up your calculator, plugging it in, taking the square root of 15, and it's 3.87 ... It doesn't terminate, it doesn't repeat, but this is the closest whole number approximation of that value. Why don't you try number 2 and number 3 by yourself? Think about what perfect squares are closest to that value, and see what you think the closest value of each irrational number is. Pause the video, and then when you're ready, push play, and I'll show you the answers. Well, we're in the hundreds. So 10 squared is 100. 11 squared is 121. 12 squared, 144. The number 130 is actually closer to the number 121. So this square root is approximately 11. So it was only 130 is only 9 units away from 121, and it's 14 units away from 144. Therefore, the square root of 130 is approximately 11. It's closer to 11 than it is 12. So that's how we get that. And then if we look at 2, the square root of 2, well, I know 1 squared is 1. 2 squared is 4. So the square root of 2 is closer to 1 than it is 2. So approximately the number 1. So here are my answers for all 3 of these problems. You've got 2 more problems. They're thinking problems. Let's read them. The square root of an irrational number is about 8. What might it be? So the square root of an irrational number, so the square root of something is about, maybe about 8. So what could it be? Well, I know 8 squared is 64. So my guess is that this number could be anything close to 64. It could be 63. It could be 65. It could be a variety of numbers that's very, very close to 64.